All right. Good morning, afternoon, or evening, wherever you are. I'm really happy to be at La BitConf again, or thank you organizers for making this happen despite everything that's going on. Instead of the salsa parties and tango parties after the sessions, we will just meet in the cyberspace. And right now on this panel, we will get into a bit heavier topic, let's say, but I'm hoping to keep our optimism because I have four excellent experts on the panel that will help us hopefully find the answers of how to return to a better privacy and censorship resistance in Bitcoin. And when I say Bitcoin, I mean Bitcoin and cryptocurrencies in general, just to avoid confusions. We have 50 minutes. And so let me please introduce, without further ado, our panelists. First of all, Claudia Diaz. Hola, Claudia.
Hola.
Hola. Claudia is associate professor and the lead of the privacy technologies team at the University in Leuven in Belgium. She has done an extensive research focused on privacy matters and the design, analysis, and application of privacy technologies. She promised today that she will open this panel with a short talk about, and I'm hoping about how to use these technologies to enhance our Bitcoiner life. And she's also a chief scientist at NIM Technologies. NIM is a really interesting project to me. They are trying to create a new web or internet infrastructure and I'm going to cite, with the goal to create unstoppable privacy infrastructure that could end corporate and government surveillance of personal user data. Then a next guest on the panel is Rocelo Lopez. Bom dia, Rocelo. Am I practicing well my languages with you? I hope so. Rocelo is a matador in the Bitcoin space in Latin America. Currently, the CEO of Stratum, a crypto services platform. He's built numerous businesses covering anything from mining to user wallets and exchanges. So I'm happy to have Rocelo here. He's also very famous for being a huge non-KYC proponent, and he's fighting legal battles with banks that are closing bank accounts to crypto services. So very, very important work, Rocelo. Thanks for being on the panel today. Also, please welcome Nathan Wilcox from zCash, or the electric coin company. Am I saying it right? Yes.
Sure.
Nathan, welcome. Nathan is dedicated to open source, secure technology, and has spent over 10 years in software development and security audits. Before zCash, he worked with Least Authority, where he held security audits for numerous crypto projects that you may as well know. And zCash has an interesting position. On one hand, saying it's a privacy coin, and then on the other, claiming that zCash was designed to be compliant with the travel rules. So I will be loving this discussion with Nathan, where I hope you can explain later a bit more. And of course, I would want to introduce Viktor Radchenko. Hello, Viktor. Привет. Viktor is a founder of Trust Wallet. They started an ICO, but then backed off, paid all the money back to the investors, and sold to Binance. Right? I'm just giving a background so people know who you are. Trust Wallet is a multi-token mobile app that also tries to promote dApps, and it will be one of the default wallets for Binance's future decentralized exchange. And I'm really curious about that and how that's going to play out within the topic of today. Before I give my word to Claudia, I would do a very fast recap on privacy and what is privacy. And the fourth agreement to the US Constitution that was, well written over 200 years ago, anchored constitutional privacy as something like a protection from unlawful or disproportionate surveillance by the government. Well, since then, we have seen a departure from protection of individual rights towards protection of the interests of the society, whatever that means. It could be a national security, public safety, or economic well-being of a country, and even stuff like prevention of crime. So not punishment, but prevention of crime, disorder, or protection of even morals. And that is how privacy is defined by European Convention of Human Rights and Charters of Human or Fundamental Rights. So you see that we have moved a lot in the privacy space, and it seems that we have abandoned the privacy by design, and we went towards accountability. And this is, and Claudia is laughing and smiling because that's her favorite topic. So I will not take much more space from you. Please, Claudia, come on stage and tell us about what you're working on in a privacy technology and how that can play out for Bitcoiners. And do we have a chance?
Thank you very much, Alena. I'll try to give a short overview. I mean, unfortunately, I don't think the internet was designed for privacy. So now we're paying the consequences. Let me minimize this so that, yes. Okay, so I was asked to talk about privacy. It's a huge topic, so I'm going to focus on a somewhat narrower problem within the privacy space, which is network level privacy. So as many of you know already, it is common knowledge by now that on-chain protection is something that you need, but it's not really sufficient. And that the on-chain information in systems such as Bitcoin can be exploited to de-anonymize transactions, contrary to what was naively think initially. But that's not what I want to focus on, because underneath the blockchain, there is also a communication infrastructure to enable the nodes to share the information, to broadcast transactions, and to mine new blocks. And this is common not just to Bitcoin, but to any distributed system where a number of participants want to jointly perform some function. They will need a communication infrastructure to be able to exchange data and make it happen. So that's the part I want to focus on, because the communication infrastructure, so namely the internet, was not really designed with privacy in mind. Initially, even all the communications were in clear text. These days, we have an increased deployment of end-to-end encryption with protocols like for messaging, like the Signal protocol, but also like in web browsing, TLS. So end-to-end encryption has made a lot of advances in the last few years, but network level metadata is still exposed by default in internet protocols. And by that, I mean, who sends the message, who receives the message, at what time the message is sent, how many bytes, how any patterns in the communication, if there are repeated communications between two participants, and any features in the data flows. So what happens is that often we have these very fancy cryptographic protocols that provide really wonderful properties, but they kind of assume that the underlying network is ideal and is not leaking any information. But in fact, what happens is that this metadata can act as a side channel. And you can use traffic analysis techniques to exploit this metadata and be able to infer information that is protected with cryptographic methods. One example is TLS. Even if you are visiting a website with TLS, I will not be able to break the encryption and see what content you're downloading. But by looking at the number of packets, the lengths of the packets, and the timing of these packets, and how many back and forth there are, I might be able to infer which page within this website you're visiting, which is not something I should be able to find out. Encryption should protect that information, and it does, but side channel information in the form of network metadata bypasses that protection. And the same happens in Bitcoin and in other blockchains. Some people have done a lot of work in this, in particular, Alex Virchukov and his team in University of Luxembourg. And they show that timing attacks at the network layer can undermine privacy in all these systems by, for example, enabling the adversary to cluster transactions that are related to the same person, even though you should have unlinkability, to link the IP address of the person sending a transaction to the transaction itself, de-anonymizing, therefore, the transaction. And they show that even in sophisticated systems such as zCash and Monero, the network metadata can be used to undermine some of the strong privacy protections that they have at the chain level. So if we think about it, like what would we want to have? What does it mean to have network level privacy? There are many properties you might want to have. Now, the simplest one is what we can call third-party anonymity. Third-party anonymity would mean that you and I are talking and we can identify each other. We want to know who we're talking to, but we don't want anybody else, any other third party, to know that we are talking to each other. So this is the simplest one. A slightly different one is sender anonymity. Sender anonymity means I can send to you a message and you would not be able, you, the receiver of the message, will not be able to know my identity. Who's the person that contacted you, that gave you some message. Recipient anonymity is actually a bit more complex. It means that I can be contacted, I can receive messages without you knowing my network address, right? So how to anonymously receive messages without advertising your network address to others. And linkability refers to the clustering of transactions. And it's a somewhat weaker property, but also very important. Unobservability becomes more difficult to achieve. For unobservability means that I would not be able to determine when you're active in the system, when you're sending transactions, and how many transactions you're sending. So your level of activity is not observable to me. And the strongest property is undetectability, and this is relevant to censorship resistance, which means that I cannot even determine that you are sending messages into the system, that you are communicating into the system. This is actually quite hard to achieve, and it requires additional technologies beyond the ones I will be introducing today. In terms of threat models, when you're looking at network threats, you typically assume the adversary has access to the network, is able to eavesdrop on the network, and you think about it, there are many, many entities that are able to do this, from your local ISP, to the person who has access to the Wi-Fi router, to, of course, nation-state adversaries like the NSA, autonomous systems, so a lot of infrastructure components have access to this information. So in these systems, you can consider that the adversary is global. This would be like a nation-level state adversary, or some adversary like of the size of like Deutsche Telekom, for example, a big telco. They have a lot of visibility. Or you can consider a local adversary, which is just like, I don't want to be identifiable towards the other person I'm communicating with, or maybe from the perspective of my local ISP. If you're these systems are distributed systems, they're decentralized systems, so you always have to consider that the adversary might corrupt a subset of the participants. And the methods that we use to analyze the security of these systems is not about looking at proofs, it's not about cryptanalysis, but it's actually about looking at metadata and doing a statistical analysis to find correlations and be able to infer things about what people are up to. Okay, so what can we do to protect network communication? So one of the most popular technologies, VPNs. I have it in gray because I don't believe this is a very good protection. VPNs are to start with a single trusted party, so they are a single point of failure. They're extremely easy to censor because I just have to censor the IP address of the VPN. But more worryingly, if the VPN is corrupted, they have all your information of all your communications. So they are a central point of surveillance that is on top of everything connected to your payment information. So I believe that they are not very good in terms of privacy protection. Then I'm sure many of you are familiar with onion routing networks, and it's in particular Tor, which is the most widely known, wide implementation of it. There are Mixnet technologies that I will be speaking about. Some of them are very old. Mixmaster is already from the mid-90s, from the 90s. And now NIM is the one we are working on, and I will be giving you a little bit of an insight into what we're doing, and others such as Elixir are also being implemented at the moment. And then there are peer-to-peer designs such as I2P or Hopper, which is also a new project. So what is shared with all of these architectures? They are overlay networks. So that means that between every two hops, there is the full internet, and from the point of view of the internet, this is an end-to-end communication. And they have multi-hop routing, which means that you have multiple proxies between the sender and the destination that kind of redirect this communication. This is not true for VPNs that only have one hop. which is why we don't consider them a very good solution. And in every of these hops, every of these proxies that forwards communication, there is what is called per hop bitwise unlinkability, which means that if I look at the bits at the input, at the bits of the output, I don't have any persistent identifier that I can use to link inputs to outputs. So typically this is achieved by using layered or nested encryptions, which means that you encrypt multiple times, such that every time you do a cryptographic transformation, the full message changes and you can no longer link it input to output. So this is what they share, but how are they different? What different properties do they offer? So if we compare onion routing to mixnets, in onion routing systems such as Tor, they are circuit-based. So that means that you first establish a circuit that goes through multiple proxies, multiple nodes or hops, however you want to call them. You use public key cryptography at this moment of establishing the circuit. And then in this establishment phase, you establish symmetric keys between the sender and each intermediary. And from then on, all the data transfers are transformed with symmetric cryptography. So this, of course, is very efficient, which is very nice. But at the same time, the downside is that you have linkability of all the messages within a data flow, because you're using the same key for all of them. So you have to know that these two packets belong to the same data flow. On the other hand, in mixnets, they are message-based or packet-based. And that means that every packet is treated independently in all kinds of ways. They are routed independently. They are all unlinkable. That also means that each packet you have to do public key cryptography with each packet in order to route it through the network, because you cannot reuse any symmetric keys that you have established. Of course, this is more expensive in terms of computation. And what you gain is that now you have any two messages that belong to the same data flow it's not possible to link them by any intermediary that might be transferring this data, which is a much stronger privacy protection. Another feature of Tor is that they do not add any latency. So basically, messages are forwarded as soon as they are transformed cryptographically. So that means that data flows are not altered. So if you look at an encrypted data flow from a web page, for example, downloading a web page, it will not be transformed very much, because the intertiming, the interpacket delays will not change very much because they are not being disrupted in any way by the intermediaries. On the other hand, in mixnets, every intermediary that mixes each of these intermediaries is a mix, and that means that it mixes packets. So what it does is it collects a number of packets and they come out in a different order. So here is not only the bits of the packet that change, but also the ordering of packets. So you cannot use like first in, first out in order to know which input is which output. And here there is one important trade-off in privacy. You don't get it for free. You will always be paying with either more computation or more latency. In this case, this is a trade-off with latency. The more latency you can tolerate, the bigger the anonymity sets you can build, and the more difficult it becomes to trace packets. What this comes down to the threat model. So Tor is built for local adversaries. So if your concern is that you don't want to be identifiable towards the website you're downloading, you're visiting, then Tor does the job. If you're concerned about your local ISP kind of profiling your web browsing, then Tor does the job. But if you're concerned about adversaries that have a broad view of the network and that can see you and your destination, then you're not protected, because it is actually possible to correlate the streams and de-anonymize them. On the other hand, mixnets are designed for global adversaries. So they assume in the design that the adversary will monitor all connections in the internet, and they are made to provide anonymity even in those conditions. So they have a stronger threat model. And of course, this comes at the cost of more computation and more latency. What about peer-to-peer? How do they compare to client-server architectures? And I consider both Tor and Mixnet's client-server architectures. In client-server, you have distinction of roles. So some participants are clients and some are infrastructure. Clients are basically, they use the system, they send and receive messages, while infrastructure are these intermediate proxies that do a job for others, namely for the clients. And if you have this kind of distinction, then you can aim for different kind of security properties for these different participants. You want to have privacy for clients, so that no information is leaked about who they are communicating with, but you want to have transparency for the infrastructure so that clients can actually check that these infrastructure components are doing the job, that they are not malicious, that they are actually following the protocol. In contrast, in peer-to-peer, there is a merging of roles in the sense that every entity is both a client and infrastructure. So here, inherently, you have this tension between privacy and transparency. If you want to make the system more private, you may make it less transparent in terms of infrastructure. If you want to make it more transparent, then you will make it less private for clients. And one of the problems that will appear is client enumeration. If I want to be a peer in a peer-to-peer system, I will have to advertise my network address. So that means that anybody who joins can harvest all these network addresses, which could be a privacy problem in some circumstances. On the other hand, in client-server architectures, they require full knowledge of the network. So clients will have knowledge of this infrastructure and then use this knowledge to route messages. Of course, this introduces some overhead in the sense that if this network is very large and is changing all the time, there can be a quite significant overhead just maintaining an updated view on the network. On the other hand, in peer-to-peer, partial knowledge is enough. So this is what makes them very attractive because you just need to download very little information to be able to join. But this makes them vulnerable to Eclipse attacks where you can basically take over the view of the network of some victims and make them believe that the network is full of these other nodes, and these other nodes, of course, all belong to the adversary, which means that these victims don't have any privacy protection. The not having a global view also makes it difficult to have public verifiability because nobody agrees on what is kind of the global view of the network that doesn't exist. And finally, a property of client server is that because the servers, you will have like, for each server is able to serve thousands of clients or tens of thousands of clients, you will have a lot of aggregation in each of these intermediate proxies. A lot of aggregation means a big anonymity set because all this traffic is coming through this mix. So with a little delay, you have already a lot of uncertainty about which input might be which output. On the other hand, in peer-to-peer, because it scales, like every time you add more peers, you're adding more senders, but you're also adding more intermediaries, the traffic is very low per peer, and that means the aggregation is very low, and that means that even the anonymity sets that you create are very tiny, and it might be possible to trace packets even if you have quite a lot of latency. Okay, so that was for the comparison. I argue that for blockchain, mixnets are best fit for purpose. Why? Because these applications can tolerate some latency. They are not like web browsing interactive applications that if it's more than a second latency, it's already problematic for users. They are message-based, so you can send your transaction and then switch off your computer, and you expect your transaction to be eventually appear be executed. So you don't have these sessions, this bidirectional channel need. We are talking about highly sensitive information. These transactions that are in the blockchain will be available forever for everyone. So you want to have protection against global adversaries. It's not just a local adversary you're concerned about. So what can you achieve with mixnets? You can destroy the timing correlations in the metadata so that they cannot be exploited for undermining cryptographic protections. You can achieve unlinkability between sent and received messages so that it's not possible to trace transactions. And you can shield the network addresses of participants towards each other so that they don't need to reveal their network addresses and therefore their locations to each other. What do you not achieve immediately with mixnets is censorship circumvention or undetectability, meaning that it's not possible to tell that somebody's using the network. If you want to do that, a mixnet is a good component, but you need more. You need, we can talk about it in the discussion. There are other technologies you need to use together with the mixnet in order to have these additional properties. So very briefly, what we're doing, we're working on a mixnet. We are people with a lot of experience in this space, so we have made a number of choices for this design. We use Poisson mixes because these give us a predictable and tunable latency so that we are able to support applications while kind of setting the latency that is tolerable for that application and be able to have multiple applications running on the system. This is not possible with many other mixnet designs. It's a layered topology. I'm a big fan of this kind of topology because it's very scalable and is the best in terms of anonymity while being very easy to analyze as opposed to other network topologies. It has the option of having covered traffic that goes in loops, so that enables an observability. It's not possible, if you use this option, it's not possible to determine when someone is using the system and what kind of volume they have in the system usage. We use a feature of Sphinx, which is the underlying packet format that is a single-use reply blocks that enable reliable transport. This is not something that previous mixnets had, in the sense that once you send a message, you can be sure that the system will make sure that it's retransmitted if it gets lost in transit and eventually delivered. And it also enables anonymous reprise, which is a very interesting feature for recipient anonymity. Clients can go offline and their messages are kept in Dropboxes that they can then pull when they come back online. and it's incentivized. So that this is, I think, very important. This is something that was not possible before we had the cryptocurrencies in the space, because it basically means that you can have an infrastructure. You don't need like a big corporation to set up this infrastructure. You can have people just running the infrastructure and being able to get rewards for their costs and their work, so that it can be economically sustainable, and you can have like kind of the end users be able to contribute towards the deployment and the maintenance of this kind of network. Of course, if you're giving rewards, you need to ensure that people are doing the job, and we have worked out a scheme in order to have a randomized sampling that gives us measurements that are difficult to bias, and that give a sense of what is the level of performance of each of the participants. The network information is available to everyone in the blockchain, so it's not possible to do eclipse attacks because the network view is global. And we integrated with some other components, which is private credentials that provides additional functionalities. This is another whole talk, so I will not go into details. If you're interested, I mean, incredible interest from the community. We're super delighted. There is like, I don't know if it's 1,000, 2,000 nodes. A lot of people are running nodes already. Basically, it already has enough capacity for all the cryptocurrency traffic. Of course, we want to also expand it for other applications. Basically, any client that is compatible with SOX5 can tunnel the communications through the NIMS system, and it's already working with Electrum, Blockstream Green, Kiwi's Chat, and more applications will be added. There is a demo in that link if you are interested. And if you want more information, you can go to the web or to Telegram, Twitter, or check the code in GitHub. I hope I didn't go too much over time.
To be honest, I don't see the timer, so I'm not sure. Thank you very much, Claudia. That's very interesting. I'll be honest, I'm not a technically skilled person, so let me just ask, how demanding or how doable is this that everyone in the Bitcoin space starts using something like a NIM network? How difficult it is to get something like this on board across the board?
I mean, in terms of capacity, I mean, it's a test net and it's obviously still being, expanded, debugged. But in terms of capacity, the cryptocurrency traffic is not so much. So in terms of capacity, it would be possible to route all the traffic via this system. In terms of usability, I mean, I think that with the SOX5 proxy should make it very easy for developers to be able to join their application with our system, so that communications are piped through there. I'm hearing. Stop sharing the screen. Sorry. Do I find the button? Stop
yes,
sharing.
there's yes. Good.
Yeah, sorry. So. So yeah, in terms of developers, it should be very easy to integrate with any client application that supports SOX5. And then how easy it is for end users, well, that depends on the client integration of the application that they have. I mean, it could be completely transparent, because you have to think this is communication infrastructure. So it's not necessary for users to really have to interface directly with that, right? It should be happening automatically in the background.
But it assumes that ISPs and everyone would one day wake up and say, you know what, we want to go back to privacy by design. And
no, we don't need them to. I mean, basically, you can have a number of people running nodes in different places of the world. And even if ISPs are recording and logging traffic, because of how this mixes operates, it's not possible to know which input message corresponds to which output message. So you have a sufficiently large user base, it becomes extremely difficult to see which inputs and outputs correspond to each other, and then you get a very good level of privacy. So you don't really need buy-in from ISPs. It's just you need sufficient people. But I mean, we're seeing that there's definitely interest to operate such a network.
So basically, it would add the privacy protection for, and if talking about crypto transactions, for peer-to-peer transactions.
Yes.
However, there is this KYC issue, and AML and travel rules. Just to give a little bit background for those who don't know about travel rule, it's a recommendation, or did it come out from the BSA or did it come out from FATF as recommendation? I think that was an FATF, Nathan.
I think it did come from the BSA, I think, not an expert.
The Bank
And
Secrecy
then,
Act introduced one part that's called travel rule.
Right.
It's been implemented in the traditional opaque banking system. It took probably several years to implement, and now it's being pushed towards crypto next year. All custodians in the crypto space should be compliant. And I would like to hand over the word to Rocelo. Because Rocelo running also an exchange, running several businesses. Are you going to comply? What do you think about these KYC rules in general? How do you prepare for that?
For sure, I'm not going to comply with, because, well, number one, I do not agree with that. And for those that never read the white paper for Satoshi Nakamoto, was pretty much straight. Part A should not know or trust on part B. So I'm stick with that one. And privacy is the most important thing. If the banks, they wanted to put their regulation, if they wanted to tell people to swallow all that bullshit that they are doing, is their problem. So bringing that to crypto, I don't think it's is not fair, especially because crypto was made to protect our privacy, was made to do that. And let's face this thing, from now on, any exchange have to disclose all the transaction. And what's happened with all that information? That information one day will be leaked. And then when that information will be leaked, we're going to be end up on the deep web. And that one thing that the regulator need to understand, when you do a crypto transaction, all you need is an address to transfer from A to B. If someone come to my house because I send the information to an exchange, or I send the information to a department of the government, and if that information is leaked, someone come to my house, put a gun in my head and play a game with me and then say, listen here, buddy, we're going to play a game here. Who's going to pull the trigger first? Are you going to me pulling the trigger first, or going to be you sending the Bitcoins to my wallet? That's it. The authorities, the regulator, they need to understand all those things, the implication that all that have, because it's not that simple. When you say I'm transferring Bitcoin to one wallet to another, all you need is an address, and that's it. So I'm complaining with that? No, I'm not going to complain with any regulation that comes to that point. And if that's the case, I have to move countries. Definitely I'll move countries. Countries will agree and will protect the user privacy. Some countries will not, maybe going to be forced because the United States are saying so. And some countries will say, fuck you, US, I'm not going to comply with that. And that can happen. And hopefully some countries will understand all these things to be protecting. And that is bullshit, that they are trying to find a way to always control your money. When you have the control of your money, when your money is not seated in a bank anymore, or in any financial institution, then they will know that they have no power over you. And the beauty about it, all the things that Satoshi Nakamoto did for us, give us freedom. If I'm not happy and living in Brazil, if I'm not happy with the regulation from Brazil, all I need is to take my Bitcoins or any other coin, zCash or whatever you have, and take away with you, and then move to some country that they will agree with. And for sure, come on, 210 countries in the world, one of them will agree with that. But there is one point that I'm always have to say. We need, the authorities, they always saying, we want to prevent something bad. We want to prevent that someone used to do bad stuff. All right, for you to prevent that, invest in education, invest much better in how you form individuals, to show the individuals what is good and then what is bad. And then after that, you go after those guys, because we're not going to be that much guys in the market to do bad stuff when you really invest a lot of money on a kid, on preventing that someone to do something illegal. Punishing the guys that actually is protecting their own privacy, it is not the way. And I'm the guy that, for everybody knows, like 3 years ago, my wife was kidnapped in Brazil, and they asked to be paid in crypto and Monero and zCash. So they knew everything about the technology. So I should be the guy to say, I am against. When the chief of police here in Brazil says, oh, we should have a law to protect, my first answer was straight, no, we should not. We should protect the users to face those kind of things. We should protect their privacy. That's what you should do. The cryptocurrency has nothing to do with that. So, and I'm still fighting against any regulation that is putting at risk someone that uses cryptocurrency.
You're fighting in the court. Any other ideas for this fight?
Well, I'm fighting against banks. I'm fighting against the regulators. And listen, I know for sure we're going to become a moment that the government, it's too hard to fight the government. It's hard to fight. It's really hard to do. But when that comes, I will move to another country. I'm going to keep doing. And most important part, when people understand that is their privacy is at risk, their freedoms at risk, and their security at risk, then when people really understand that, they also has to start to fight to it. Do not just give your ID to an exchange. Just do not do those things, because that's exactly what you're doing. The best way that technology has been provided to us, like Claudia said, there is a lot of technologies coming out. There is a lot of possibilities. Well, we have someone from zCash here today, which is a very good coin. It's a very protect our privacy very well. So we have someone from Trust Wallet, which I use too. We have our own wallet, but I also use their wallet. It gives you some protection when people really understand that. So then I think the regulators, they have to go back to lab and find another solution.
Nathan, would you please jump in with how zCash is fully compatible and compliant with the travel rule, and for that matter, any other crypto, because you have a great explanation on your website about that.
Sure.
And also, if I may, another question. Do you or don't you feel like there is a dichotomy between being a privacy-focused coin and talking openly about like we are compliant and everyone should do, or that's how it kind of felt when I was reading your blog?
Right. Okay. Well, the first question's easy. If we're talking about the US, which I'm most familiar about, so the travel rule in the US is a requirement that money transmitters, which are licensed institutions, when transferring money between themselves on behalf of customers, they must include with that transfer the information about who the customer is, like what account they have, what's their address. It's kind of an older law, right? So it's like you need their snail mail address. Who cares about that anymore?
And by that include, you mean to include in some separate database?
My understanding is that when the law was created, which I think was in the 70s, or it could have been earlier, I thought it meant include the information with the transfer details. So like if it's a wire transfer between banks, they have to say which customer owns these funds, or who is the recipient customer and who's the sending customer. So that's my understanding of what the travel rule is in the United States. And again, it only applies to money transmitters, which are institutions.
Or virtual asset service providers, as they try to frame them.
Right.
I also understand that as for the moment, the travel rule applies for assumptions of money being sent abroad, which is in terms of crypto, well, it's quite impossible to determine. So we could assume that those rules will apply just basically to any wallets, regardless of whether it's an interstate or international transfer per se. And it should be limited to $3,000. So the reporting mechanisms should start there, but there are already proposals for decreasing these levels to $250. I'm not sure how far is that from reality.
There's a few different things that we should pull apart. So the travel rule is just that one, as my understanding, is just that requirement to include that information in the transfer. And then there's separate regulations about um, reporting suspicious activity, where institutions are responsible if something nefarious happens, and they could have noticed something suspicious, but they don't. They can get in trouble, and so the financial institutions have developed this kind of tier of crime detection and prevention, which is not. It's in the private sector. It's not part of law enforcement directly, but they've developed this because they're on the hook to do so. And that's a little bit different. So that has rules like if a transfer is over this amount, it's automatically suspicious and you have to report it to the government in the US. So zCash is compliant, can be compliant with the travel rule if the institution that's transferring funds is a regulated money transmitter and they're generating the zCash transaction, which means, by the way, that they hold the private key. So it's not the user holding the private key. In that case, zCash has something any user can use called the encrypted memo field, where they can attach just an arbitrary message with any transfer. And so financial institutions could use that to fulfill the travel rule requirements if they're using zCash shielded transfers. So is that clear as to how it can be compliant? Uh-oh, I think you're muted.
Pardon me. So this won't happen when we have a live event, because the mic will be mostly there. What was I saying? Yes, so this is applicable for zCash, however, not easy to do or not even wanted to do in other cryptos such as Bitcoin, I'm assuming.
Yeah, so in another, so if you don't have that feature and you want to follow that understanding of the rule, which may be changing, you need some other system to transmit user identifying information between these institutions whenever you're transferring funds. And I know that there's different folks trying to provide solutions like that for exchanges. And I think just to follow on what Rocelo was saying, there's this danger. So maybe with the best intentions, regulation could be done really well in order to protect people, but there's always a trade-off, and it's by collecting KYC information, we're introducing a vulnerability, especially if that becomes centralized. So I would be really concerned about solutions to some of these regulations, technical solutions that end up centralizing data. So like there's one service provider that's the most popular that has like the travel rule API or whatever.
Yes, that's coming.
That could be disastrous regardless of the privacy features of the coins themselves.
Well, I believe that's precisely what's coming. Blockseer is launching a mining pool that will have all these compliance features. What does it mean for actual Bitcoin network, or for that matter, any crypto network, if we have mining pools that have these the logic built into the system and could potentially just decline UTXOs that are on a blacklist or exclude? What kind of implications does this have to the network security in general? Are we going to see Bitcoin divide into black and white market money? And maybe Claudia, if you could finalize this topic, and this is a question for everyone, if there's any way networks such as NIM could help Bitcoiners regain some privacy. But
I will very shortly, I will say privacy has many layers. And if you want to be private, you have to protect it at all the layers, because leakage of information at one layer will undermine the protections that you have at other layers. So I don't think that one single technology can solve all the privacy problems that we have, but we need to have technologies that address all these pieces so that we ensure that we don't have leakage on any of these layers. And I think what NIM provides is the network layer protection, But of course, other things like on-chain protection have to be provided, with other technologies.
That is true. Viktor, first of all, how do you think about these measures that are being implemented worldwide, whether it's a US type of travel rule or Swiss? What are the implications for someone who is running a Bitcoin wallet service? How are you going to or not to comply with anything like this? And what are your outlooks on solving these issues for the Bitcoiner?
Yeah, I think the way I look at it is that we have a technology that is permissionless. So it means that I don't need to comply with anyone. As long as I comply with the code, I'm good to go. So I think that's kind of the way to look at, the way we look at technology now. Because before, we did not have any technology to, have this kind of opportunities. And so when you think about, open systems, open source systems, and open blockchains, it's all about like being independent and run things by your own and be fully like permissionless. So in this case, it's not up to a specific product even to either comply or not, because if the code is available, so anyone can just come in and run the node, run a wallet, or run even an exchange or anything they want. So in this case, you can probably censor or put some KYC on some products or companies that are based in specific jurisdictions. But at the same time, my perspective on this is that we have such an amazing opportunity to build products which are open source and available for anyone to use. And it doesn't require to be compliant with anything because it defeats the purpose of what we're trying to achieve. So we're trying to give, privacy to people. So it's not on the level just of like blockchain specifically, but also on the level of like personal privacy. So I don't think the future we want to live in where, social networks like spy on us, they collect all the data, they send us all the ads. And then, so I think, same thing with blockchains, right? Like I don't want to expose, lots of personal information, all the transactions. So ideally, I want to have an option to choose what options I have and then pick the best solution for me. So maybe some people don't really worry about much privacy, so they will pick one coin or one blockchain. Some others will, select to use mixnets, or they might have to go even higher privacy. So I think it's good to have the type of options. And so if we talk about, KYC, I think it mostly included to like centralized companies who hold funds for the users. But if we look at on the side of like non-custodialship, I think we want to give all the power to the user to decide what they want to do.
Mm-hmm. And so you are going about it by implementing cross-chain swaps, or what is your technical solution to allow people to, do currency shopping or?
So the way we look at it, we just want to, find all the best options, all the best protocols out there to integrate into the wallet. So currently we support, different cross swaps functionality. We support swaps on, other protocols that, live on different blockchains. So in this case, we don't really tie to a specific kind of product. We just rely on trustless protocols out there. So in order to integrate any functionality on the product, we need to make sure that the service we're going to use is going to be trustless. So in this case, if you want to do any type of swap, it has to go through the smart contract that we can audit. So in this case, it's not going to go through some centralized API, and then there's going to be someone who will be doing some magic to give you coins back. So I think we want to make sure that the products are built, they're like trustless in that sense. And so it gives all the power to the user.
However, even Binance is starting to implement KYC, for what I know. That has changed from the past, where there was one of the known KYC parties in the market. Does Trust Wallet do KYC currently?
No, we don't. I mean, we're a non-custodial wallet. It's not that we have a choice. Like, we don't have a choice. It's a decentralized wallet, so we cannot do anything. It's users' power to control their funds. So it's not up to us to decide either we want to do or not. So
and that is, I think, the most important feature of Bitcoin ever. In 2020, and I will probably just close with this idea and not even gather your. I'm sorry. Oh. All right, that was very little time to go through all.
That's right.
But
Okay.
thank you.
Thanks a lot.
Bye-bye.
Bye-bye.
Thank you.
Bye, guys. Bye.
bye-bye.